This video shows how to solve an equilibrium problem that would be rather difficult to do analytically. And in this problem, we have nitrogen and hydrogen in equilibrium with ammonia. Now, the letters in brown are what's given in the problem. Everything else is the work. So this is what's given, the equation. And the equilibrium constant K is also given. Now, Kp or Kc doesn't really matter. It's calculated both the same way. If these are concentrations, it would be Kc. If these were pressures, these would be Kc and Kp. The concentrations initially are given. Our task here is to find what the equilibrium concentrations are if K is given. This would be rather difficult to do mathematically, and you'll see why in a moment here. First, we calculate what Q is. Q is the equilibrium quotient, and it's based on the initial values. Q is calculated exactly the same way as K is, except the calculations are not equilibrium calculations. The concentrations are not equilibrium concentrations. So I took the amount of ammonia, squared it, and that's on the top of the fraction. And on the bottom of the fraction, the amount of nitrogen times the amount of hydrogen cubed. And that all comes out to 7.2. That is less than K. Q is too small, it needs to increase. And so because Q needs to increase, the products are going to increase in concentration, so I put a plus here, and the reactants are going to decrease in concentration. I'm going to put a minus here. Now, the reaction goes to the right because Q is less than K, and that's why the products are positive, the reactants are negative. If Q were greater than K, if Q were something like 750, then the products, I would put a minus 2x here, and a plus x, and a plus 3x here. Also, it's possible, in fact very frequent, that one of the concentrations that you have initially is 0. And you know it's 0 because the problem will either tell you it's 0, or it's simply not mentioned at all in the problem. The problem might say nitrogen, a certain amount of nitrogen and a certain amount of hydrogen are mixed in a tank, and no mention of ammonia initially is there. So in which case you just assume that it's 0. If you have 0 of something, then you don't bother calculating Q. And in fact, if you have 0 on the reactant side, you can't calculate Q. You end up with divided by 0. So instead, just note the reaction moves in the direction of whichever side has the 0. So whichever side has a 0 in it, that side ends up being the positive x, and the other side ends up being negative. All right, well, in the end, I just get that from just adding the initial limit change. Now, before I use Excel to try to mathematically solve this thing, let's explore a little bit what the limits of x are. I know that x has to be positive. I set it up that way. I set up x to be a positive number because I chose which side to be positive, which side to be negative, based on which way I knew the reaction was going to go. But there's a maximum value that x can have. On the reactant side, whichever side of the reaction that we're subtracting x, I solve for what x would be if the concentration were 0. And for the nitrogen, x would be 0.1. For the hydrogen, x would be 0.167. So those are upper limits, so I choose the lower one. And so that's going to be the upper limit to how high x can be. Any higher than that, then I'm going to get a negative concentration of something, which I can't have. Now I'm ready to do the actual calculations in Excel. Now I'm breaking this down a little bit differently than the way I did it in class. I'm calculating the concentrations of nitrogen, hydrogen, and ammonia separately. This is actually a much better way to do it. And then based on that, I get what Q is. Now K was given to me, it was 250. So I'll just go ahead and key that number in. And for the x, I know that the 0 was, that has to be at least 0, but 0.1 was the limit. So I just split the difference as an initial guess and put 0.05 for x. Now I calculate the hydrogen, the concentration of nitrogen. Concentration of nitrogen is equals 0.1, don't forget to put an equal sign at the beginning of the formula. 0.1 minus, and then for x I just click on the number or key in A or just type in A1. For the hydrogen, it's equals 0.5 minus 3 times x. Click on A1. And then for the ammonia, equals 0.3 plus 2 times, and click on A1. So based on all these values, I get Q. So Q now equals the amount of ammonia squared, because of the 2 of the coefficient in the equation, divided by, and then in parentheses, the amount of nitrogen times the amount of hydrogen cubed. And so that gives me a value for Q. By the way, watch what happens when I put a value of 0 for x. Now Q ends up being the Q that you originally had at the beginning. X is 0, the reaction hasn't, x represents how far the reaction has proceeded. I'll go back to where it was now. Now I see my K here, and I can put in different values of x until I get a value close to K. And you notice that as x increases, Q increases. Keep that in mind. As x increases, Q increases. And 0.07 puts it pretty close. So I'll put it there for now. Now the difference between K and Q, this is how far you need to go to reach K, equals the value of K minus the value of Q. Now this is a negative number because Q is already a little bit too large, so I'll have to subtract a little bit. So to make a new approximation, I take the value of x, and then because as x increases, Q increases, I put a plus here. Now, if it were the opposite, if as x increases, Q decreases, then instead of putting a plus right here, I would write a minus. So keep that in mind. As x, watch what happens as x increases. Try different values of x. And if x goes up, if that causes Q to go up as well, then you put a plus right here at this point. And this is my new approximation for x. So my new approximation of x plus the difference. The problem is that I made a correction that's way too extreme. X can't possibly be negative. Small changes in x, we can see it over here as we try 0.06. Watch what happens to Q as we do this. Small changes in x cause very large changes in Q. When x is 0.07, Q is 264. When x is 0.06, Q is down to 134. So it's very small changes in x. So I don't need to adjust x by that much. So going back to that formula here, it's going to be the x plus the difference divided by, and then I'm going to divide by some factor so that it doesn't cause too extreme a change. Let's make it 1,000 and see what happens. So this x now, instead of 0.06, it's 0.175. Let's see what happens when I put that number in, 0.175. Whoops, I got a negative concentration of something because even that's too big. So I'll go back to what I had before, 0.06, and go back down here to this formula and make the division, make the quote of the divided by an even larger number, 10,000 instead of 1,000. So my new x now becomes 0.0715. I'll put in 0.0715. And now Q goes down a little bit. My new approximation is 0.0669. Q goes down as well, and so on. 0.0707 now. Q's now a little bit too high, but that's okay. It's eventually going to converge. It looks like it will eventually converge. So now we're going to set it up to do an iterative calculation. So to do an iterative calculation, we need to set up Excel to make sure that we don't stick it with a circular reference here, because we're going to purposely put in a circular reference. So now, under Excel, go under File, and under the bottom there's Options. And the second option there is Formulas, and under Calculations Options, make sure this box is checked that says Enable Iterative Calculation. Now, I put the maximum number of iterations, I think by default is 100. I put it up to 1,000. And the maximum change I put as 10 to the minus 9. It has to be some non-zero number here, so it doesn't get stuck in. So this number, I guess it has a limit of 32,767, and the maximum change, I guess you can put it as small as you like, but I put 1e minus 9. Should knows what that means. And then you type OK. And I put these limits in there so it doesn't get stuck in doing this forever. So now that I have it set up for iterative approximations, I'm going to close the loop. And to close the loop, in place of A1 here, we write equals and then what the new approximation is. And then it's going to keep calculating, come up with new approximations and new approximations. Let's see what happens. Hit return. Okay, it looks like the concentrations of all three of them are positive numbers, so that's good. And we also see that the difference is a very tiny number, something times 10 to the minus 10. So that means that it seems to have converged on a solution. Now, if you end up with some kind of crazy number, like a negative number here for the concentrations, and maybe some huge number for the difference, then that means the calculation did not converge. And so, if that happens, take a look at your formula at the bottom here. Look at that formula and check. Maybe that divisor has to be larger, or maybe you forgot to put whether it's plus or minus here. Maybe you put the wrong thing. Remember, it's plus only if as x goes up, q goes up, which is the case here. But it's conversion of solution here, so we're finished here. The concentration of nitrogen and hydrogen and ammonia, all three of them are listed here. Thank you so much for watching.